contour on xy plane, where the partial derivative of x square plus y square with respect to y is equal to partial derivative of 6y plus 4x. Do you know the meaning of partial derivative? But you studied partial derivative. What is the meaning of engineers always relate the concepts with physical quantity. If you relate mathematical concepts with physical quantity, you will remember it forever. You will remember it forever. So first, let us see what is the difference between dependent variable and independent variable. Dependent variables and independent variables. If they are orthogonal, they are independent variables. If they are perpendicular, they are independent variables. I will take a cone. Its height h is known, r also known. What is the volume of this cone? 1 by 3 pi r square h. 1 by 3 pi r square h is the volume. Here r and h are independent variables. Because if r increases, then cone becomes like this. R decreases, cone becomes, if it slightly increases, cone becomes this. But it will not affect the h. That's why r and h are independent variables. Independent variable. Independent variables. That's why here we can apply partial derivative. You can find dou v by dou r. Because h is independent and you can find dou v by dou h. We can apply because h and r independent variables. On the other hand, I'm taking the same cone. The variable here is r and L, slant area. The slant area of this cone, surface area of this cone equal to pi RL. Here you notice that R and L are mutually perpendicular. They are not mutually perpendicular. So they inclined some angle. That's why R and L are dependent. This can be physically verified. If you increase R, what will happen? L also changes. So L and R are dependent variables. So if you increase R, L increases. If you increase L, R increases. So L and R are here. You cannot apply partial derivative. That's why you have to slant surface. ds by dr. If you apply L also involved, that's why you have to apply total derivative. You have to do ds by so equal to, here you have to differentiate R while keeping L constant. While differentiating L, you have to differentiate with respect to R. Even if you differentiate with respect to R, you have to differentiate both because R and L are dependent. You will get like this. What you will get is, if you differentiate with respect to R, you will get pi L plus if you keep pi r constant, and if you differentiate dl by dr, you will get, but what is the value is different. But this is the difference between these two. Here it is not so. If you differentiate with respect to r, h will be mingled with the constant here. It is not so there. You will get like that. So here partial derivative equal to partial derivative of 6x plus 4y. The contour xy plane where the partial derivative of x square plus square with respect to y is equal to partial derivative of this with respect to y is equal to partial derivative of 6y plus 4x with respect to x. So what is partial derivative of dou by dou y of x square plus y square equal to 0 plus partial derivative. That's why the other variable is constant. Therefore, you will get 2y. Then dou by dou x of partial derivative of 6y plus 4x equal to what? Um, equal to what? X means 4. So they are related. The contour on xy plane where the partial derivative of x with respect to partial y with respect to x is the contour is in the x plane is therefore 4 2y equal to 4. Therefore y equal to 4 by 2 equal to 2. Y equal to 2 is the contour. Y equal to 2 is the contour. They are related by these two relations. So that relation is y equal to 2. That is the answer. So here we are differentiating this with respect to y. While doing partial derivative, the other variable is constant. Similarly, while differentiating this with respect to x, this y is constant. Therefore, here you are getting 4. Here you are getting 2y. If you equate these two, you got the relation. That is y equal to. The relation is y equal to 2.